Object-oriented programming is, in actuality, what the C# language is based on. Now, on the 70-43 exam, not only are they going to expect you to understand syntax and different functionalities that you can build with the C# programming language, you also need to understand some of the underpinnings, and one of those is object-oriented programming. Now, if you've been around for a while, you're very comfortable with this. If you're relatively new, then this could be a bit of a problem for you, and it might even be worthwhile, if you've got a little experience, to watch through this as well to kind of refresh some ideas. A lot of the topics that I'm going to talk about through this section on object-oriented programming will appear in some form on the exam. So what exactly is object-oriented programming? And you will also see it referenced out there as OOP. It is simply a programming model. It's a way we think, a way we program, a way we structure our programs in a form that organizes and utilizes code that is much more efficient than earlier programming models that we used. Now, the best way to understand the advantages of object-oriented programming is with a little history. Now, way back when I first started programming, my wife, for our first wedding anniversary, way back around, I think it was around 1980, bought for me one of the best anniversary presents she's ever done, and that was a Texas Instruments TI-99 4A home computer. I hooked this thing to the television. I think it had 256K of RAM, and I thought that was cool. I thought the Enterprise had landed at my house, and I began to try my hand at getting some serious programming done, writing little games and so forth. Now, I was using basic programming, and the way we wrote programs back then was the program was a bunch of sequential lines. And they were actually numbered 10, 20, 30, 40, 50, 60, 70. And we numbered them that way because sometimes we'd realize we needed lines in between. So we'd go between 10 and 20 and put 12, 13, 14, and 15. Then there was a renumber command. We could always go back and renumber. Now here's the deal. When we ran the program, it got loaded into memory. It started at the first line and it went to the next one, the next one, the next one, and the next one. And the program ran in the same direction all the time. Kind of think of top down, from the lowest numbered line up to the highest. And it was always kind of like gravity trying to move to the next highest line number. And the programming really was more concerned with logic rather than the data that we were working with. Because once I got a variable to a certain value, I really had to watch in the way my program was looping around that the variable stayed the same value that I thought it was. Otherwise, my logic would get messed up and I wouldn't generate errors, but I would generate some pretty bizarre outcomes. Now, the branching in the program, since it was always trying to run to the bottom, we had to keep branching it back up to the top and doing all kind of things. And this created what became known as spaghetti code. The program was constantly jumping everywhere, and you constantly had to check variables and change them and readjust them and all sorts of things. And as you can imagine, these kinds of programs were extremely difficult to update and maintain, and they were very famous for one aspect, and that is when you went in and changed one thing, it broke about 73 others if there was any complexity at all. Then along came the idea of object-oriented programming, OOP. Now remember, I went and I sat in a training class with this really intelligent lady that taught me programming, and it was fascinating. But I couldn't get my head around it for 2 or 3 days because it was such a unique, different way of what I'd always been trained to think about programming. With object-oriented programming, the program's broken into objects or code structures that mimic real-life objects. Now, each one of these objects is separate in memory from the rest of the program. It's its own unique little memory creation, and as a result, the object can be created in memory when we need it. We can then, from within that object, write some code to go out and connect to a database, load the properties of the object up, the account holder's first name, last name, address, zip, telephone number, what happened their last visit, do they owe us any money. We can manipulate that data, write changes back into the database, and then simply discard the object, take it back out of memory. And so we've created changes, we've read from a database, we've created changes, we've persisted those changes back into the database, and then we just simply free our memory up and go on to the next item. Now, each object contains a code functionality that's unique to that particular object as it was defined in the class that was used to create it. Now, there's a lot going on in that sentence. Don't worry if you didn't understand it all. We're going to come back to that later on when we talk about classes and objects. Now, each object exists to encapsulate or to hold and even somewhat hide and manage our data. So it encapsulates the functionality of how the data gets managed, and it actually manages the data. So theoretically, the program that we write, its real job is just to create these objects from classes and manage the objects, and the code is supposed to kind of tie all the objects together. So let's do a real quick example here, and we'll end part 1 and finish this up in a part 2. Let's talk about an object-oriented example of, we want to write a program about baking a pizza. Well, baking a pizza involves 3 main real-world objects. You need an oven, you need a pizza, and you need a person to turn the oven on, put the pizza in, and take it back out. Well, each object, an oven, a pizza, and a person object, can exist independently of the others in the program. Each of these objects is created in memory only when it's needed, and each object can very easily be later updated, changed, expanded without affecting the others. We can make changes to our oven object and never affect the pizza or person object. So we don't have to change one thing and see 73 others get broken. So that's where we're headed with object-oriented programming. So I'm going to end part 1 here. Join me in part 2, and we'll take a little bit deeper look at object-oriented programming.